So next, see a pod services config map and namespace, replication controller, replica set, deployment and stateful set and daemon set. These all are comes under deployment resources in the Kubernetes. So storage and backup, empty directory, host path, persistent volume, claim storage classes, CSA drivers. These all are comes under storage and backup. So auto scaling, horizontal pod auto scaler, networking, ingress and network policy. So role-based access control, RBAC, cluster role, cluster role and cluster role binding, role binding. So we'll discuss all about these components and service account as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23 services, 23 resources. Hands-on will do every session. So now going to pod. So understand here. It's the Kubernetes cluster. If you deploy Kubernetes cluster inside pod, so you can Kubernetes cluster having multiple worker nodes, right? So define worker nodes. This is the worker node. I have deployed one pod here. And one more pod also deployed. So this is the worker node. So worker node 2. Now understand the pod. What is about pod? Here pod is a smallest deployment unit in the Kubernetes cluster. So it represents single instance of running process in a cluster. So it encapsulates one or more containers. So pod contains one or more containers. So pod contain one or more containers. So Why you are creating multiple containers means, so here take first container as a Nginx. So in Nginx, responsibility is taking the HTTP request and response, getting the response. That is the main role of Nginx controller for each and every service. So additionally, we are using one more container here that can be called as a sidecar container. Means this sidecar container capturing the main pod container logs or metrics. So those metrics collected and keep it in somewhere. So in that cases, we are going to create multiple container inside the pod. So pod is nothing but a combination of multiple container. It is a, so you can say like that. And automatic unit. So pod represent a single instance of running application or process in Kubernetes. It's the basic building blocks of deployment. So pod is a building, it is a print like. So without pod, you cannot deploy any applications in the form of containers. So that is about automatic unit. So next, group of containers. A pod contains one or more containers. So already I defined like, so that the tightly coupled and shared resources such as networking and storage. These containers are scheduled and run together on same node. So when pod is created, these container, these all container running on same node. This is one node. This is worker. This is one worker node, and this is worker node 2. This is the cluster. Next, shared resources. How containers share resources across the pod. So containers within the same pod share the same network namespace, IP address, port space. They can also share storage volumes, allow them to communicate with each other and share data. So like that, resources can be shared like from each and every container from pod. So life cycle, pod life cycle. Pods have life cycle that includes various states. One is pending status, pending state and running state, suc succeeded state and failed state, unknown state. These five states are comes under life cycle. So Kubernetes manages life cycle of the pod, ensure that they are always in the desired state. So desired state already you know. If it is 3 means 3 by 3, 1 means 1 by 1. So that is the life cycle. It is saying each and every state, pending and running, succeeded, failed, unknown. These are the life cycle of the pod Kubernetes manages. So pods are immutable. Pods are considered immutable once created. If you need to update a pod configuration or containers, you typically create a new pod with desired changes rather than modifying existing one. So Here once pod created, we can't change the resources. If you want to change, you need to update the definition file. See here. So typically create new pod with desired changes. So you can change any modifications in the new deployment. So that modifications will happen in a existing one. So created one, that is about immutable. So here controller. Pods are typically managed high-level controllers in Kubernetes. So already we discussed Kubernetes cluster components. So backend they so here high-level controller. So namespace controller and endpoint controllers and stateful set controllers. So those type of controllers, when you deploy the resources, background Kubernetes components create these controllers and manage high-level components such as deployment, stateful sets, and daemon set. These controllers ensure the desired number of pods are running and handle scaling, rolling updates, and other management tasks. And pod specification. When create a pod, you define its specific specification in a YAML or JSON format. So include details such as the pod name and content and images. What are the images you need to use? Resource requirements, environment variables, volume to mount. So you need to define in the definition file these pod specifications. So that is about pod. So next coming to service. See the service object. So these are the pod. We are going to discuss about service. So service, what it can do. So here After creating pod having multiple container, right? So if you want to access this service means any nginx or anything. So if you want to access this to external, so in that case we need to use service mapping. So there is a selector section in the service. There is a selector. So pod definition file. So there is a labels. So in the definition file, we'll see the labels while executing the live deployment. So this is understanding purpose only I'm explaining. So how will managing these pod IPs they- so dynamically service Kubernetes service. So here once in the cluster pod is created. So after some time, some issue, so pod is terminated or something will happen. So in that case, when pod is recreated, immediately new IP is added to this pod. So in this case, service Kubernetes service maintain background component is a service discovery. In the service discovery, it is keeping this existing pod IP. So here, so service of this service Kubernetes service managed these pod IPs. So if it is pod crashes, then immediately it is it is taking from existing IP to assign to this newly created pod for same service. So consistently it is manning the so pod IPs. So this is the best if you want to communicate this pod traffic to this pod. So mandatory this Kubernetes service is mandatory. So you can you can understand more theory. So here three types of service objects are there. You can say service objects or service modes. You can call as your wish. One is cluster IP. This is the default service object for Kubernetes. Next one. Third one is a load balancer. These three are, this is the cluster IP is the default Kubernetes service object, and node port is the statically we define the specific port. So by using this node port in the service definition file. So load balancer is dynamically assigning the node port, creating node ports. So we'll understand while deploying these service objects and all. Here, cluster IP exposes the service on internal IP address within the cluster. So exposes the service on the internal IP address within the cluster. Remember this. So this is the default service type. So node port. Next, coming to node port. The node port. So node port exposes the service on the static port on each node IP. So load balancer. So load balancer creates an external load balancer in the cloud provider as a network and assigned to stable external IP. The service. So how will manage this background network mechanism? There is a component called service discovery. This service discovery services enable service discovery within the Kubernetes cluster. So each service is assigned a static IP address. So each service assigned static IP address and DNS name that are that other pods can use it to access it. So here the service object assigns static IP for this pod. So if you want to communicate this pod to this pod, that IP is mandatory, the static stable IP. So when a pod needs to communicate with other pod, so it can use DNS name of the service to resolve to corresponding set of pod IPs. So that is about service discovery. Next, pod to pod communication. This pod and this pod communication, how will happen? So here, when a pod wants to communicate with other pod, so that belongs to service. So this service, it simply sends the traffic to service DNS name and port. The service when uses its selector. Here pod have one selector and service have one selector. Here pod and this this selector, this label contain this pod label matches, then automatically this traffic will communicate with each other like that. And forward the traffic on the one of those pods. If multiple pods match, the service can load balance the traffic across them. If multiple pods means, so load balance, DNS load balance the traffic across them. Here one more component is a service endpoint. So these points are very important. These endpoints are very important to communicate the pod. So here bind the sense a service maintains a list of endpoints which are the IP addresses of the pods that belongs to the service. These endpoints are dynamically updated as a pod or created, deleted, modified. So here that is saying, so when pod is created, deleted, if you want to change this in happen means anything happen, pod will crashes or recreated. So immediately this service will keep that IP and assign to the that particular pod. So this is the service endpoints will take care about these things. Service controller continuously monitoring the cluster and update the endpoints accordingly. So backend service controller. So when creating this service object or backend, it is creating service controller. This service controller continuously monitoring the pods. So when it is crashes and something will updated immediately, that are updates dynamically assigned to the particular pod. So that is about service.